So I am so sorry that this is so late, and what I am going to say is I will not make these videos anymore the night of, so I won't ever do this again. So I am very sorry. But this section is 5.4, Sum and Difference Identities. So we are going to be continuing to use those sets of identities, that list of identities, and this one's the one that we're focusing on. So now what we know about these identities are there two expressions set equal to each other for any value that you could plug into those expressions. And what we know is because they are equal, we can substitute. This has allowed us to do many manipulations, and we're going to continue to manipulate, and we'll see that it's going to be doing us some favors by being able to manipulate or substitute. So sum and difference. You might look at these. These are towards the bottom of those identities that I gave you in that list. The sum and difference is what we're looking at. So we're going to want to be able to recognize when we would use the sum and difference identities, and what I would say is it's when you have the sum or a difference of these trig functions, these main trig functions. So you might look at this and ask yourself, now why would I ever want to sub this in because it's very complex? Well, we're going to look at an example down here. So this down here, if you were to add 3 pi over 4 plus 5 pi over 6, you could do that, okay, because this is in parentheses. So you could go ahead and add those two values that you're trying to take the sine of, the two angles. So here, if I did that, I'd need a common denominator, so I'm going to multiply this by 3 over 3, this by 2 over 2. Okay, and what we would get here is 9 pi twelfths plus, and then 10 pi twelfths. Now, once you got to this point, you can just go ahead and add straight across the top and put it on over the common denominator. What we would find is a problem, because we don't have any segments where we had broken these into twelfths. So we have no ability to calculate sine of 19 pi over 12 using our unit circle. So that's why this manipulation of subbing this out, recognizing that we are taking the sine of the sum of two angles, and subbing this in would be beneficial. So that's what I'm about to do. So here we're going to be plugging this in exactly. Sine of the first angle, I'm going to do that part. Sine of, here's the first angle being summed up. Okay, times cosine of the second. Cosine of the second, because you can see here, here's the second piece being summed up, and this is the second piece in this situation. And then plus, we have cosine of, and then this is going to be the first, so 3 pi over 4, times, and then sine of the second piece. So here's the second piece, 5 pi over 6. So where we couldn't evaluate sine of this whole thing, what we can do is break it down into these pieces right here. So now what you will notice is you can locate 3 pi over 4 on your unit circle. If you took pi, divided into 4 equal pieces, we would be looking at these pieces, right? Here's my pi. And so I want 1, 2 thirds, 3 fourths, sorry, this was 1/4, 2 fourths, 3 fourths. So we're going to evaluate this triangle right here for its sine value and really its cosine value. So let's go ahead and look at that. Remember that sine is the y value, cosine is going to be the x value. So with this reference angle, we're going to look across the way at the opposite over hypotenuse, which is always 1 on the unit circle. And what we would find is this is the y value, the square root of 2 over 2. This one right here, the cosine, would be the x value of that triangle, and it is negative because it is going backwards from the origin, so negative square roots of 2 over 2. Alright, those were those two pieces. Okay, but then we also have to look at cosine of 5 pi 6 and sine of 5 pi 6. We're just evaluating this piece at a time. So I'm going to now go ahead and plug in what is cosine of 5 pi 6. Well, let's locate 5 pi 6 on the unit circle. That's this special 30, 60, 90 triangle. Okay, so here is that 30-degree reference angle, and the cosine of this would be the x value. So that's this guy right here, or the adjacent over hypotenuse to that reference angle. So here we would have negative square root's 3 over 2, that longer leg of that 30, 60, 90. And don't forget our plus. And then sine of 5 pi over 6 is going to be the y value, so 1/2, the shorter leg of that 30, 60, 90 triangle. So now if we were to go ahead and multiply all this through, we have the square root of 2 times the square root of 3, so negative square root's 2 times square root's 3 all over 4, multiply straight across the tops, straight across the bottoms, plus, and then we're going to have negative square root of 2 over 4. Now one thing I want you to note is that if you ever have a square root times a square root, you can put these underneath the same radical. So what you get is the square root of 6, and then don't forget they're negative, minus the square root of 2, and these are all over 4. But because we have a common denominator, we can go ahead and just put that all over 4. Alright, so this one's done. Alright, over here what I will do as well is note that we don't have any sum and difference rule for this, so we want to note the difference between this versus this. The other thing you want to note is that you can't just distribute this, it's not going to get us the same. And sine isn't a number to be distributed. Sine, you're trying to take sine of some sort of angle, or in other words, in this case, the sum of angles. So sine is not a number to just merely distribute. And if you ever tried to do that, you would get the incorrect answer. Sine of, and then the sum of those angles was equal to this. If I did want to do something like this, you're going to see it's very different from this. So sine of 3 pi over 4, we can go ahead and evaluate it. There's no reason to use any of these. We can go ahead and just do this. Sine of 3 pi over 4, that was, again, this angle right here. Sine value was the y value, so it's the square root of 2 over 2. Plus, and then sine of 5 pi sixths, that was this triangle right here, and we want the sine of it, that was this piece right here, so that is 1/2. So then we can just go ahead and add this, the square root of 2 plus 1 all over 2, you can see very different. So to just go ahead and try to distribute that would not be an accurate way to go. You would not have gotten out, wound up with this. So note the difference between these two, make those notes, and then also see that, hey, this is something where we could use the sum and difference on. This we didn't use any identities on. Alright, here's another example. So it says find the exact values of sine, cosine, tangent, and tangent of the given angles. So here's the thing, you're given this, okay, and we want to find the sine of this 105 degrees, or we want to find sine of the 60 plus 45. So since we want exact, we wouldn't have been able to evaluate sine of 105 because again, it's not on the unit circle. Okay, so I mean it's approximately right around, right around here. Sorry, more right around there. But the problem is, like, there's no special triangle to fit in there. Right? So let's go ahead and evaluate these because we can evaluate those. So what is sine of 60 degrees plus 45? And I know it's ugly, but once again we can say, hey, let's take this and use that instead. So we're going to take sine of that 60 degrees times cosine of that 45 degrees plus, and then now cosine of that first angle times sine of that second angle. Alright, so now we're going to evaluate these. Locate where 60 degrees is. It's right here. Okay, and we want sine of it, so that's going to be our y value. We have the square root of 3 over 2, and this time I'll just go in order instead of over here. So then cosine of 45, so here I want cosine of this 45 degree angle. I found that on my unit circle. I want cosine of it, the x value, we're going to have the square root of 2 over 2. Plus, now we're going to go cosine of that 60 that we had observed earlier. So 60 degrees is our reference angle. And we're going to look at the x value because I was wanting the cosine. So that's that shorter leg, 1/2. And then sine of 45, we're going to look back over here, and that's this. So the square root of 2 over 2. So here we go. I'm going to go ahead, multiply straight across the tops, I'm going to get the square root of 6 all over 4 plus the square root of 2 all over 4. Our final answer is the square root of 6 plus the square root of 2 all over 4. Okay, so now we're also going to do this for cosine because it does ask us to evaluate all three. So we're going to have cosine of 60 degrees plus 45 degrees. This one's a little bit different, so you're just going to be using this exactly. We're going to take the cosines of these. So cosine of 60 degrees times cosine of 45 degrees minus sine of that 60 degrees times sine of 45 degrees. Alright, so here we go with the 60 degrees. You can even look up here. We've already evaluated some of those, so or you can look back at your unit circle. But cosine of 60 is going to be that 1/2, that shorter leg. Cosine of that 45, well 45 we always know is the square root of 2 over 2, and we're in the quadrant 1, so they're all positive. Minus sine of 60, sine of 60 would be that longer leg, so the square root of 3 over 2, times, and then sine of 45, the square root of 2 over 2. Okay, so now to simplify that, we have the square root of 2 over 4, that's when I multiplied the tops and the bottoms, I got this, minus, and then we're going to multiply those, and again, because they're both underneath the radical, you can just take 3 times 2 and put it underneath the radical, all over 4, so we get the square root of 2 over 4 minus the square root of 6 over 4. And then finally, tangent of 60 degrees plus 45 degrees. So this one might be a little bit different. We're going to have to be a little careful of this one. Tangent of 60 degrees plus tangent of 45 degrees all over 1 minus tangent of your 60 degrees times tangent of your 45. The nice thing about this is you're going to be just doing tangents, but the bad thing about this is we're going to have a lot of fractions. So let's go ahead and do this. Tangent of 60, when you look over at 60, it would be the opposite over the adjacent, TOA, remember. So I'm just going to evaluate this off to the side because I'm getting kind of squished down there. This thing right here is going to be equal to the opposite, over the adjacent, so opposite over adjacent, or y over x. So here, what we do have then is the square root of 3 over 2 times 2 over 1, because I multiplied it by the reciprocal instead of dividing it by this, and those reduce, so we get the square root of 3. So up here I have the square root of 3 plus tangent of 45. Hopefully this one's going to be a little bit easier. We have opposite over adjacent, and since they're the same, we just have all over 1. Okay, and then we have now 1 minus, and we just evaluated those, so the square root of 3 times 1. Okay, I'm not even going to write that. So there we have it. Alright, actually that wasn't so bad. Just don't forget that we had to do those. Alright, so this is your homework assignment. What I will say is we did number 2 and we did number 7. Okay. What you will see is for 16, 17, 18, 19, and 20, what they actually wanted us to do is evaluate the sine, cosine, and tangents of what they gave as angles. This one we're just going to do sine. Okay, so those two just sine. This just evaluate the cosine, and these just evaluate tangents. So what I will say is I'm going to do a 16 with you and say exactly what they wanted us to do. So they want us to evaluate, I'm going to say just sine of this negative 105 degrees. So first of all, you might be looking at this and thinking, my gosh, like how do I evaluate negatives? Well, first of all, we could always add 360 if we wanted to. Correct? So what we would be getting there is if we subtracted these, we would get, so if we added these, we would get sine of and then 255. So the idea is this is the same exact thing as this. They are what we call those coterminal angles. You go back 105, so that would be, back a little past the 90, a little bit past the 100, or you could go forward 255 and wind up in the same direction. Okay, so now here's the deal though, this still isn't on the unit circle. So this is where we might have to play around with this, and let's make this into a sum of some angles that we already have. So let's play around. I mean, I have this 5 here, so what if, this is going to take a little bit of time, you could try to subtract 30 off from this and say that it would be sine of, and then 30 plus, or 30 degrees plus 225, right? So then you would want to look and see, alright, are those on my unit circles? And they most certainly are on your unit circle. So you could totally use this if you want. There's other ways that you could do this as well. You could have maybe made this as sine of, and then 60 degrees plus, and then if you subtracted off 60 degrees from that, what would we be at? 185. Okay, so this probably wouldn't be, oh no, sorry, I did that wrong. 195. This wouldn't be ideal because we're not, again, this 195 isn't on the unit circle. So I kind of got lucky with this. You could, again, maybe find some other ones, like let's say we subtracted off 90 here. We would get 5, and then 145, no, 165. Do we have that on our unit circle? No. Okay, so I kind of got lucky, but you are going to have to do some guesses and checks here, and this is my first guess and check, and it was a successful guess and check. So what we are going to do is evaluate this by using that right there. Okay, so I'm not going to go through that, but what you will do for 16 instead then is you're going to rewrite this maybe into something that's coterminal and then maybe break that apart. Otherwise, you might have been able to find the difference of two values here that you could have also used. There's many different ways you could have written this. Alright, so there you have it.